Hello guys, let's see how we can solve this, which read x to the power of x to the power of 3 is equals to 27, and we are looking for the possible value for x. So if you are new here, kindly subscribe to this channel and turn on the notification button so that you get notified whenever I drop videos on mathematics. So let's see how we can solve this nice challenge. So say solution. Okay, so write the question, which is x to the power of x to the power of 3 is equals to 27. Okay, the next thing we can do is to multiply both sides of the equation with a natural log. So if we should do that, we are having ln x to the power of x to the power of 3 is equals to ln 27. Okay, so we've done this, okay, note, so if you're having ln of a to power of b is also equals to b ln a, because this will be coming to the back. So if we should apply this principle here, we have this to be x to the power of 3 times ln of x is equals to ln 27. Okay, so this is what we are now having. So since we are having this, so what are we simply going to do? Okay, we can rewrite this side of the equation. Note, if you're having a times b is also equals to b times a. So if we should put this principle here, we have this to be ln x times x to the power of 3, which is equals to ln 27. Okay, so this is what we are now having. So we can write x to the power of 3, x to the power of 3 is also equals to exponent ln x to the power of 3, because this exponent will cancel this ln. So if we are having our a, is equals to exponent ln a. So this principle is what actually we applied there. So x to the power of 3 is also equals to exponent ln x to the power of 3. So wherever we see x to the power of 3, we can substitute this into it. So if we should do that, we have this to be ln x times exponent ln x to the power of 3 is equals to ln 27. Okay, haven't done this. Recall this principle we wrote at first, that ln of a to b is also equals to b ln a, because we said this will be coming to the back. So if we should put this principle at this point, which is this 3 will be coming to the back. So we simply have this to be ln x times exponent 3 ln x is equals to ln 27. Okay, haven't done this, we can see that this 3 has come to this back. Okay, so we are now having ln x times exponent 3 ln x is equals to ln 27. Okay, so we are now having this. So we are having this, So what then is the next step? So we are now having this. I really want to apply the Lambert W function, which says if you're having b exponential b, and we should take the Lambert W function of it, b exponential b. If we take the Lambert W function of it, it's also equals to b. So if you're having star exponential star, we should take the Lambert W function of it, it's also equals to star. Okay, but if you look at this left hand side very well, we're having ln x times exponential 3 ln x is equals to ln 27. Okay, so what are we going to do to make this base to be the same as this exponent value here? So what are we simply going to do is to multiply both sides of the equation with 3. So if we should do that, we also say you multiply both sides of the equation by 3. So if we should multiply both sides of the equation by 3, we have 3. We're having 3 ln x times exponent 3 ln x equals to 3 ln 27. Okay, so this is what we're now having by the time we multiply both sides of the equation with 3. So now we cannot take the Lambert W function of both sides. So if we should do that, we say the Lambert W function of 3 ln x times exponent 3 ln x close bracket is equals to the Lambert W function of 3 exponential 27. Okay, so we've taken that, okay, so we've done this. We cannot say, remember we said a Lambert W function of b exponential b is equals to b. So this is a separation. So if we take the Lambert W function of x star exponential star is equals to what? Star. So if we should take the Lambert W function of 3 ln x exponential 3 ln x is equals to what? 3 ln x, right? Which is equals to, so this remains the same, Lambert W function into 3 ln 27. So this is what we are now having. So if we move further to solve here, so we are now having 3 ln x equals to the Lambert W function into 3 ln 27. Okay, 3 ln 27. So if we want to look for ln x, we can divide both sides of the equation. So we can say divide both sides of the equation by 3. So if we divide both sides of the equation by 3, we are now having ln x is equals to the Lambert W function into 3 ln 27 or divide by 3. Okay, so this is what we are now having. So we can say ln x is equals to Lambert W function to 3 ln 27 over 3. Okay, so we are now having this. We want to look for the value of x. So if we want to look for the value of x, we can take the exponent of both equations. So we have this to be ln exponent ln x is equals to exponent of Lambert W function into 3 ln 27 over 3. Okay, so having done this, this exponent will cancel this ln. So therefore our x is equals to exponent of the Lambert W function into 3 ln 27 over 3. So this is the value of x. This is the value of x. And the real value of x, if you point this in the Wolf and Manfred calculator, our x equals to 1.78. Our real x become 1.78505. So this is the value of x when you punch the whole of this in a Wolf and Manfred calculator. This is 1.78505. So if you find this video useful and interesting, please click on the subscription button and turn on the notification bell if you have not done that. And please don't forget to hit on the thumbs up button. Bye for now. God bless you. Jesus loves you. And see you in my subsequent video. Bye bye.